Welcome to YouTube channel Chem to Fame, and in today's class we are going to discuss very conceptual questions based on aromaticity. In first question it is asked that which of following ketonic compound is least stable. So we have to correlate the relation between stability and reactivity. So if least stable compound is to be converted into reactivity, then we can use the relation that reactivity reactivity is inversely proportional to stability. So we have to see that which of following compounds are most reactive. So one by one we will discuss. In first option, C double bond O, C double bond O. These are the ketonic group. And this carbonyl carbon as well as this carbonyl carbon is sp2 hybridized. So carbon atom adjacent to sp2 carbon is sp3 carbon, and this sp3 carbon will be treated as alpha carbon, and hydrogen attached to alpha carbon is alpha hydrogen. This alpha hydrogen has got acidic character. So what we will do, we will convert this ketonic group, keto group, into enolic form, and these two forms are interconvertible. So how we will draw the enolic structure of this compound? So we have to do from this carbon atom, if we are removing hydrogen in form of H plus ion, then this bond will get terminated into carbon carbon. At the same time, carbon oxygen pi bond gets dissociated heterodytically, and oxygen atom will acquire negative charge. Likewise, we will remove H plus from this carbon atom. Again this carbon carbon double bond will be formed, and in order to maintain the tetravalency of carbon, this carbon oxygen pi bond gets dissociated heterolytically, and this oxygen will acquire negative charge. These two negatively charged oxygen will accept this H plus and will get finally converted into OH group, and this ring will have double bond in conjugation. So here we can put OH group, here also OH group, this carbon carbon double bond, and here also carbon carbon double bond is formed. So we have converted ketonic form into enolic form. This is enol. Why it is called as enol? Because this molecule is having carbon carbon double bond, means alkene part, that is in, and carbon oxygen alcoholic part. So collectively it is called as enolic group. But we are seeing that in this ring the completely delocalized system is not available. This ring is having only 4 delocalized electron. These two carbon atoms are sp3 hybridized, and to this carbon delocalization does not reach. Therefore this ring is not completely aromatic. Since it is not aromatic, so it has got, this product has got, this enolic form has got lesser stability. If this is less stable, it means this reactant molecule is more reactive. In second molecule again, we will convert this into enolic form. We can put like this: hydrogen will be removed in form of H plus, this carbon carbon double bond will be formed, and this pi bond will be terminated to oxygen. Likewise, H plus is removed from here. Again this is carbon carbon double bond, and this O minus will abstract H plus to form OH group. So its corresponding enolic form will be, here we will put OH group, here double bond, again OH group, and here also double bond. This ring is also not aromatic, so this compound is also not more stable. Since it is less stable, therefore it is more reactive. In third molecule, we can convert this ketonic group into enolic form like this. From here, if we remove H plus ion, then this carbon-carbon double bond will be formed and this oxygen will get negative charge. This negatively charged oxygen will get H plus ion to form OH group. Likewise, we can remove hydrogen from here. Carbon-carbon double bond will be formed and this pi bond electron will go to oxygen to form negative charge and once again this negatively charged oxygen will get H plus ion to form OH group. So its corresponding enolic form will be like this. Here we will put OH group, here also OH group. Here we can put double bond, here also double bond. This ring is also not aromatic, so this enolic form is also not more stable. In last molecule, this keto form could be converted into enolic form like this. From here, if we remove H plus ion, then this double bond will be formed. This negatively charged oxygen will get H plus to form OH group. Again, from here H plus is removed. This double bond will be formed between ring and this pi electron will go to oxygen and ultimately C double bond O will be converted into OH group. Likewise, from here also we can remove H plus ion and this carbon-carbon double bond will be formed and this will be finally converted into OH group. So we can write its enolic form like this. This C double bond O will be converted into OH. Here also OH group. Here also OH group. And this ring will have 3 pi bond in conjugation. Now it becomes aromatic ring. Aromatic ring. Since enolic form of this molecule is more stable due to aromaticity, therefore this D molecule will be more reactive. It is highly stable and this is highly reactive. Since D molecule is highly reactive, therefore this D molecule will be least stable. Therefore, correct option of this question is D. So, here in box we can write correct answer is D. I hope this keto-enol tautomerism will help us to determine which of the following molecule is least stable and final answer we have obtained on the basis of aromaticity. So here it is additive concept of aromaticity as well as tautomerism. In second question, here dihalides are given and the reagent given is SbCl5. This antimony has higher affinity for chlorine. So this antimony will abstract chlorine atom from these two carbon atom. Since this carbon chlorine bond is highly polar due to electronegative difference between sp3 carbon and chlorine, therefore this Cl and carbon bond gets dissociated heterolytically and after heterolytic dissociation these two carbon atom will acquire positive charge. So its structure will be ring is already having 3 pi bonds in conjugation and these two carbon atom will acquire positive charge. Now we are seeing that this double bond positive charge, double bond positive charge are in conjugation. So this ring has got complete delocalization throughout the ring and it has got the aromatic character. And due to aromatic character, stability of this compound becomes very high. It is more stable compound. And now these two positively charged carbon will have its counter ion, that is negatively charged ion, 2SbCl6 minus. So due to aromaticity, this part is highly stable, as well as these positively charged centers are well compensated by negatively charged ion. So the most stable form of product in this question is B. Therefore, the correct answer of this question will be B, and the main reason for this answer is being highly stable compound because of aromatic character. So these are very important questions for JEE and NEET, and we in successive videos we will see many questions based on aromaticity which are most probable for JEE and NEET. So please put your comment, and I will try to give the base concept through question in my later videos. Thank you.